All right, in this video, we're going to be expanding on the Edpuzzle video that you watched. Just a little recap. From the Edpuzzle video, you learned the two apparent functions for the sine of x and the cosine of x. So we're going to be expanding on those just a bit today, and we're going to be talking about some properties of these graphs. So the sine function you saw looked like this. Starts here at 0, has this pattern, goes like this in both directions. So sine and cosine are both what we call periodic, meaning the same shape repeats over and over again and just keeps going over and over again. So with the sine function, it actually starts here at 0, and then it goes through one cycle, and then it ends here at 2 pi. And that's the same place where our unit circle ended, right? The sine function goes up to 1 in the y direction, and it goes down to -1 in the y direction. And it just repeats this pattern over and over again. So some things that we're going to talk about: midline, amplitude, and period. So with the sine function, the first thing we're going to talk about is the midline. The midline is exactly what it sounds like. It's the line that goes through the middle. So if I were to find the middle of this graph, it's going to be right here at 0. And the midline is just an imaginary line that divides it in the middle. So the midline of sine would be at the equation, we just say y equals 0. So an invisible line at y equals 0 that sort of divides this thing in the middle. The cosine looked very similar. The cosine graph, the only difference was it starts up there, and then it repeats the same pattern. So cosine starts up at 1, still goes down to -1, and one cycle of this still ends there at 2 pi. So we would say it's also 2 pi periodic. So really the only difference is it's just kind of shifted a little bit. Cosine starts at 1, sine starts at 0. Both of these, again, also have the period of 2 pi. Cosine would also have a midline at y equals 0 as well. The questions that we're going to be asked to solve on Delta Math here are going to be sine and cosine functions, except they're going to be have gone through some transformations. So if you think back when we did like polynomial transformations and things like that, where like we can add 1 or subtract 1 or multiply it by 3 or even put a negative and reflect it, we can do the same thing to sine and cosine functions, because you won't always see just the original parent function of sine, original parent function of cosine. Often they're going to have gone through some transformations. So for instance, this first graph here, it starts up there at 1, goes through a cycle. It ends that first cycle there at 3 pi. So this looks like the cosine function, right? Because it's starting up there at 1, it goes down to -1. Just the only difference is instead of having a period of 2 pi, it has a period of 3 pi. So it's the cosine function that has a little bit of a transformation. For right now, you don't need to know what that transformation is. We will get to that in the next couple videos. But just note that this is a cosine function. And for this problem set, all you have to do is find the middle of this function. Most of you are going to be able to find this just visually by looking at it. And you'll just be able to see, oh, the middle is right there. Just going to draw a little imaginary dotted line. So the middle of this function occurs at y equals 0. So midline would be y equals 0 on this function. They won't always be maybe quite this easy. There is a little formula that you can use for the midline, which I'll show you as well. Or if you can't visually see that, that's fine. There's a mathematical way of getting that as well. The formula that you use is y equals the max value, the max y value, minus the min y value over 2. Sorry, actually that's a plus. Max plus the min over 2. A little handy formula you can use there as well. So if I were to apply this to this problem, I'd have y equals my max value, if I were to draw a line up here, is at 1. My minimum is down there at -1. So 1 plus -1 over 2. Well, 1 plus -1 is 0. So 0 over 2, which is 0. So either way, not too challenging to find the midline of these functions. Let's go and type that in and look at another one. Okay, our next function. This one actually looks like the cosine function as well, because this one's starting up at 2, but if you look at one period of this, notice it does go up higher, so it has a maximum value up there at 2, so that's been stretched, and then also the period is 6 pi. So the original cosine function had a period of 2 pi, but this is just the same thing repeated over and over again. Let's see, right? All we're concerned about on this particular problem set is the midline. And again, you'll probably just be able to visually see it is there at y equals 0. It's not always going to be the case, but you will be able to see it there. It's at y equals 0, divides in half. If we were to use our formula, y equals the max value is 2 plus the min value, which is -2 over 2. And it would be the same result, 0 over 2, which is 0. So we'll get a little more interesting one on the next one, hopefully here. All right, yeah, definitely a little more interesting on this one. Okay, this function might be a little bit more challenging to see which one it is. You don't have to identify it at this point, but it's good practice. You can see this one starts here, and if I were to just sort of trace the shape, it starts there, and then it's going to repeat the next pattern after that. So then I'm going to repeat again. Right, if I were to sort of just do this thing over and over again, we're going to be identifying these in a few minutes. This is called the period. But at any rate, you can see that's actually the sine function, and it's been shifted down a couple. The period also is now 3 pi over 2, so the period's been changed and it's been shifted down a little bit. We're asked to find the midline, so you might even be able to just identify this one again. Probably just see it, so this dotted line right through here would be the midline, and you'll see that that's at -2. If you did want to use the formula, y equals the max value here is -1 plus our minimum value, which is -3 over 2. That gives us y equals -4 over 2, which is -2. You've got to make sure you do type in that y equals part. All right, let's show you just one more. Here, this one is the sine function as well. It's been shifted up. And for the midline, all you're looking for is the line that divides in the middle. You can see it right there. So that's going to be at y equals -4. If you were to use the formula, max value is 5, min value is 3. 5 plus 3 over 2 is 8 over 2, which is 4. So either way, not too challenging. Y equals 4. All right, our next problem set, we're going to be finding something called the amplitude. When you think of, or when you see the word amplitude, you want to think just height. How tall is this function? But the height isn't just the overall height of the function. It is the height from the midline to the top or bottom, so min or max. So we're going to have to find the midline in all of these. And then after we find the midline, it's going to be the height from that midline to the top or the height to the bottom. So let's go ahead and identify the midline of this function. This function looks like the cosine function because it's starting up here, right? It doesn't start in the middle, it kind of starts at the top. So this would be the cosine function. And as I said, we need to find the midline of this function. This one's actually a little bit trickier to find the midline. You might not be able to visually see this one as well. So I'm actually going to, let's go ahead and use our formula to find the midline first. So the midline of this function, y equals our max value, goes maximum height there is 1, plus our minimum height there is -5. So 1 plus -5 over 2. That gives us -4 over 2, so it's -2. So I'm going to go ahead and draw the midline on there. It's at y equals -2. So there's my midline, and the amplitude is defined as the height from the midline, so from my red line to the top, or midline to the bottom. It's going to be the same because it's the same distance. So I need to figure out what's the gap between there. The easiest thing to do is probably just to count. So for my midline, if I were to count up, I got 1, 2, 3. So my amplitude would be 3. So A equals 3. If I were to count down, it'd be the same results. 1, 2, 3. So the amplitude would be 3 in either way. The amplitude is always positive. You always say it's positive. It's always positive. You wouldn't say -3 ever, because height is not a negative value. You can't be -6 feet tall, right? You can be 6 feet tall, but you can't be a negative. So amplitude is height. But again, it's kind of just half the height, if you will. Height from the middle to the top or middle to the bottom. Okay. So we are going to just type in the value 3, I believe, here. It's not an equation. It's just, again, a value. It's a height. All right, let's try another one. So the amplitude of this one, you can probably find the midline on this one relatively easily. Midline is just a line that goes through there. So the midline of this function looks like it's right there at y equals 1. So the amplitude of this thing is the distance from here to here. Right, pretty easy to see, it's just 1. All right, so the amplitude is 1. All right. There is actually a mathematical way of finding this one as well, which I can show you. Let's go ahead and I'll show you the math value on this one. I think in general you'll be able to just identify, well, where's the midline? It's right there at y equals 1. So then the height or the amplitude is from 1 to 2. So that's just obviously 1. The mathematical way of finding this amplitude is very similar to when we found the midline. It's just going to be your max minus your min over 2. So the midline was your maximum plus your min over 2. Amplitude is your max minus your min over 2. I don't expect you'll really need to use this formula because, again, it's pretty easy to just see the amplitude on most of these. But your max value there would be 2. Your minimum value is 0 over 2. 2 over 2 equals 1. So same value we got either way. Right. This one, okay, this one is a little bit more challenging, so that's good. All right, on this one, let's say you can't visually find this. You can't visually find the amplitude because maybe you don't know where the midline is. So let's use this little formula, our max minus our min over 2. So our maximum value of this is 1. So amplitude is going to be 1 minus, remember midline is plus, 1 minus our lowest value is -3. So 1 minus -3. Just be careful with your signs there, over 2. So that becomes 4. 1 minus -3 will become a plus. So that's 4 over 2, which is 2. So the amplitude of this function would be 2. Proving this using our midline, the midline would be at -1. And then so the gap to the bottom obviously is 1, 2. The gap to the top is same, 1, 2. So there's our amplitude. All right, and the last thing we're going to talk about is the period of the function. All right, so a period is, the easiest way to describe that is one cycle. One cycle of the function before it repeats itself. So if I were to look at this given graph here, this is a cosine function because it's starting up higher, it doesn't start in the middle. So this function goes down and then back up and ends there, and then we're starting in the same spot again. And then it repeats this pattern, goes down and back up. And if I were to also go in the negative direction, starts here, it goes down and back up, So each one of these different colors is a period. This is a period. This is a period. This is a period. So when we're asked to find the period of the graph, we're looking for basically, this is going to be looking at x values. Whereas all the other ones we've been looking at y values, we're going to be looking at the x values in this one. Period is sort of the length in terms of the x values. Period is how far is it from when I start the period to when I end the period. And this one you'll see my starting to my ending of this one is from 0 to 8 pi. So the period of this function, our p equals 8 pi. And then if I were to look again, this one starts at 8 pi and it ends here at 16 pi. So 8 pi to 16 pi is another 8 pi. So 8 pi here, there's 8 pi here, and then there's 8 pi here. So each one of these periods till the function repeats itself is 8 pi. If you remember on the parent functions, the parent cosine function starts and ends, it is 2 pi periodic. So this one starts and ends at 2 pi, and then it would do another cycle, it ends at 4 pi, right? It's at 0 here, it would be a negative 2 pi over here. So it's 2 pi periodic. This one has been transformed a little bit. It's been sort of like stretched out horizontally. So its period is 8 pi. So we're going to go ahead and just type in 8 pi. There is a formula which we'll use for this one as we move on. This one I think is visually is probably the easiest way to at least identify the start and the end. So if you wanted to sort of have a formula for this period, it's just going to sort of be the end of the cycle minus start of cycle. And I'll show you what that means. All right, so the easiest thing that I found to identify these is to always, if you can, this works on almost every case, is start where it crosses the axis, the y-axis there, where x is 0. And then basically you can either trace it or just identify where it hits that point again and it's completed a cycle. So here's one cycle. And this is the sine function, because notice it's starting sort of in the middle, whereas remember the cosine starts at the top. So in order to complete one period, like one cycle of this thing, well, we start at 0 in the x direction and we ended at pi over 2. Remember, we're looking at x values for this. This tells us like the horizontal length. So this period would be pi over 2, because the end of my cycle is pi over 2 minus the start of my cycle is 0. Pi over 2 minus 0 is obviously pi over 2. So if you start at 0, that makes the addition subtraction part of it really easily, because it's just always whatever the end value is minus 0, so it's just that end value. So if you're able to find that point and look at it that way, that is what I found to be the easiest way to identify these. Let's go ahead and look at another one. Yeah, this is the cosine function, because notice it's starting up here high. It doesn't start in the middle. So this has a period like this, and then it's going to start that pattern over again. So then it would start here and go down again and back up again. Same in the negative direction. Starts here, goes down and back up. So when we look for a period, again, I always like to find where it crosses the y-axis. So from right here would be my start, and then this cycle ends here. So from there to there, that is one period. Well, it's just going to be pi, right? That's because it ends at pi minus 0, so it's just obviously pi. Okay. That's all we type in, pi. Let's try one more here. So for this one, this is going to be a cosine function, because again, it's starting at the top. So one period, if I were to trace this, starts there, ends there, then it's going to start again, So each one of these repeats itself. All of these have a period of, well, here's my start, here's my end. So it ends there at 2 pi over 3, so the period is 2 pi over 3. And I don't know if you don't know if you know this, but you can also just hit 2 and then type pi, and it will change it to pi. You can obviously click there too, but 2 pi over 3, it's a little trick. All right, I think that's all that you will encounter. So if you are struggling with any of these, make sure that you are reaching out to me. Remember, there's always these extra little help videos here as well. All right, good luck, guys.